So the next couple of problems say to graph the following inequalities. If it's already in slope-intercept form, which I reminded you up here is y equals mx plus b, then all you have to do is find the m and the b and graph the line and shade above or below. Okay? If it's not already in that form, then you probably want to put it in that form if possible. As a reminder, if you have less than or equal to or greater than or equal to, then it's a solid line. But if you have strictly less than or strictly greater than, you're going to have dotted lines. Okay? Let's see here. So the first problem, number 7, has it in slope-intercept form. Y is less than or equal to negative 3 2/3 x plus 6. So the slope is negative 2/3. My y-intercept is 6, so I can just plot my point at 6. Then my slope is down 2, right 3. I'm going to repeat that a couple times. Down 2, right 3, down 2, right 3. I could also go up 2 and left 3. Now, because we have or equal to, it's a solid line. Also, because it's less than, that tells me I'm going to shade below. So I'm going to go ahead and draw my solid line, and then I'm going to shade to the side below the line. If you have a hard time deciding which side is below, pick any point on the line and put an arrow straight down. That is the below side. If you were trying to shade above, again, pick any point on the line and draw a straight up arrow, and that will be the up side. Okay, so just in case that's hard for you. All right, the next one, y is greater than negative 1. So on this particular problem, you can either do it m and b. The m in this case is 0 because it's like 0x minus 1, and the b is negative 1. That's one way of thinking about it. Or you can think about it because it's only got one letter. It's a special case. In this case, it's a Hoy problem. So I can go to negative 1 and just draw a horizontal line. That works the same with b. If b is negative 1 and I go up 0, right 1, because the slope is 0 over 1, then I would get a point right here, and I'd still get the same line. So either way you want to think about it, I think Hoy might be a little bit easier, but anyways, let's see. Because it's greater than or equal to, this tells me it's a solid line, which I actually already drew. Because it's or equal to, and because it's greater, that tells me I'm going to shade above. So now I'm going to come in and shade above my line here. Ooh, the shading doesn't have to be pretty. Okay, next problem. Number 9 is not in slope-intercept form. Do you see how this y is not solved for itself? So what I'm going to do is I'm going to actually solve for y. So I'm going to add 4 to x to both sides, which gets me 3y is less than 4x plus 12. I like the x to be in front because that's my mx. Then I'm going to divide by 3. That gets me y is less than 4/3 x plus 4. My m is 4/3. My b is 4. Because it's less than, that tells me I have a dotted line, or a dashed, however you want to say that. And because it's less than, I'm shading below. Okay. You always want to do that from here. Just in case you divide by negative and you have to flip your inequality, you want to make those decisions, dotted or solid, and shade below from that line right there. So I'm going to go to 4 on my y-axis because that's my b. I'm going to go up 1, 2, 3, 4 and right 3, or down 1, 2, 3, 4 and left 3. Looks like I can keep going left here, so I'm going to do that. I can put a dotted line here, and I'm going to shade below. Okay, number 10 is the only problem that we cannot put in slope-intercept form. You can't put it in slope-intercept form because there's no y to solve for. So this is a special case Vux problem. It's a vertical line at 4. Because it's less than, this is going to be a dotted line because there's no or equal to. So at 4, I'm going to draw a vertical dotted line right here Excellent. Now, I cannot shade above or below because I'm not actually comparing to y. All the other ones I compared to y, so y is less than, so it's above or below. Y is greater than, above or below, okay? In this case, I'm comparing to x. So when I'm comparing to x and not y, and this is the only case that that works on, you're going to be shading either left or right. Because x is less than 4, you're going to be shading the left side. Excellent. Our next section is to factor. Factor completely. Write prime if appropriate. Please show any work and box your answers. Now, there are at most one prime problem on this test, okay? I think there is one prime problem on this practice exam, so if you don't know the answer, putting prime on like half the problems is not going to be very helpful, so should be a little bit careful about that. Okay, going through our steps, when we're trying to factor, the first thing you look for is a GCF. So on number 11, can you find a GCF between 27 and 64? Nope, and there's no x's that can come out either. So GCF isn't going to help us. Step 2, do you have 2, 3, or 4 terms? Well, you have 2. Because you have 2 terms, you have to decide which binomial formula works. In this case, it's a plus, so that's a sum. And because the little exponent is a 3, the only possible thing we can use is sum of cubes. So let's check to see if that works. We need the first term to be a perfect cube, and we need the second term to be a perfect cube in order to do this. What cubed gets you 27? Well, that's 3. What cubed gets you x cubed? Well, that's x. So 3x times 3x times 3x does give you 27x cubed. 64, that's 4 cubed. Okay, so I can do this problem. This is the problem where you have a binomial and a trinomial. On the binomial, the 3x and the 4 just slide in. No cubes. That one's pretty easy. It's the trinomial that's a little bit tricky. So if you think about each of these terms as a product, the first term is going to be the first times itself, the first, so 3x times 3x. The last term of the trinomial is going to be the last thing in the parentheses times itself, and then the one in the middle is just one of each, like it's a little compromise, okay? So the first one's like 3x times 3x, so you get 9x squared. And the last one's like, no, 4 times 4. So, and then if you want to get in the middle, you're like, okay, I'll take one of yours and one of yours, and that gets you 12x. I know that's kind of silly, but that's just how I remember it. And then the signs, I remember those by cleaning up the problem with your soap. So if your original problem had a plus, then this is going to be the same. Your original problem had the plus, so the next one is going to be O for opposite, and then the last one's AP, stands for always positive, and that is my factorization. The 3x plus 4 can't factor anymore, and the 9x squared minus 12x plus 16 can't factor anymore either. If it could have, it would have factored in the formula, and it didn't. Number 12, there is no GCF between 49x squared and 36, so GCF is out. The next step, 2, 3, or 4 terms. Again, I have 2 terms. So because I have 2 terms, I have to decide which formula I'm going to use. Because there's a minus, I know that's difference. And because the exponent is squares, this is a difference of squares. Okay, so what is being squared to get 49x squared? Well, that's 7x times 7x. To get 36, that's 6 squared. Now, this one is the easier one. Not the cubes, I think, is a little harder, but for some reason, students forget the easy one, even though they remember the soap and all that harder stuff. They don't forget this one, so please be careful about that. So the 7x goes in both fronts. There's like a binomial and another binomial. So the 7x goes in the fronts. The 6 goes in the backs. One is a plus and one is a minus, and it's that simple, but for some reason students have a struggle with that one, but they'll get the difference and sum of cubes, but so just don't forget about the easy ones, okay? Number 13, again, there is no GCF between x squared, x, and 1. 2, 3, or 4 terms? Well, there's 3. So because there's 3, that means it's a trinomial. Now, which trinomial is it? Is it an easy trinomial or a harder trinomial? Well, because the leading coefficient is 1, that tells me it's an easy trinomial. Okay? So, in the easy trinomial, all you have to do is you put an x and x in the front, because the only way to get to x squared is x times x, right? So, that's why it's the easy one, because there's only one choice there. You're looking for two numbers that multiply to the last term 1 and add to the middle term's coefficient also 1. So two numbers that multiply to 1 yet add to 1. Well, the only things that multiply to 1 are 1 times 1. 1 times 1 is 1, but 1 plus 1 is not 1. So I just don't think there's anything that multiplies to 1 but also adds to 1. So I'm going to cross this out, and if it doesn't have a GCF, if it doesn't factor using your factoring skills, and there's nothing else you can do, then you can put prime. Again, there's at most only 0 or 1 primes on the test, so don't just go willy-nilly with all your primes. The last one on this page, we have x to the 3 plus 5x squared minus 16x minus 80. There's no GCF because the last one doesn't have any x's, the first one doesn't have a coefficient other than 1, so there's no way you can do that a GCF. But 2, 3, or 4 terms. Well, in this case I have 4 terms. The only thing you can do with 4 terms is grouping. So what I'm going to do is I'm going to group my first 2 together, and I'm going to group my last 2 together. In my first 2, x cubed plus 5x squared, just looking at that, in fact you might want to just cover up with your fingers the red group so you're not worrying about them right now. Between the first 2 I can factor a GCF of x squared out. Even though the whole thing doesn't have a GCF, if I pair it up in groups they do have GCFs within each group. In the second group, the red group, negative 16 and negative 80 have a GCF of 16. Now I have to choose a sign here. In fact, I chose a sign on x squared too, the blue one. Whatever the first terms in the group is, that sign, then that's what you factor out. Because my x cubed was positive, then when I factored out the x squared, it was positive. But no one writes positives in the front. That's a little funny, right? In this case, the 16 is negative, so I'm going to factor out a negative 16 out of the second group. When you divide negative 16x divided by negative 16, you just get positive 1x. Negative 80 divided by negative 16 and is going to be a positive 5. A lot of people get the x to be positive correct, but then they'll forget it on the 5. I don't know why. Negative divided by negative is a positive. So make sure you get that. Looking at the two groups, it looks like x plus 5 is a common factor. So we have x plus 5. In the second group, I have the x squared from the blue group left over, the minus 16 from the red group. And if I box this and say I'm done, then I've missed something. What did I miss here? Well, the x squared, because it has a squared in it, it's possible I could factor some more. So this one is a difference of squares. So what squared gets you x squared? X, and m's x. What squared gets you 16? Well, that's 4 times 4. And the difference of squares, like we did on number 12, says that one sign has to be positive and the other sign has to be negative. The x plus 5 simply comes down.